Welcome back. Here's in another topic. We're going to work on chain rule and we're going to implement chain rule. Here is the chain rule that you know of. We're just going to go through two examples of chain rules, and one is a little bit simpler, the other one is more involved. So stick around to the end so that we know how to use chain rules step at a time. Okay, so it's algebraically heavy, so stay tuned. Here is the first thing that we got to do. First, we're going to rewrite this function square root of x cubed plus 1 as exponential form. So this becomes x plus 1 the power of 1/2. Okay. Once we have this, now we're going to go ahead and take the derivative. And according to the chain rules, first we have to deal with the entire thing. So 1/2 comes to the front and becomes x cubed plus 1 to the power of -1/2. And then you have to multiply that by, so here is the g prime of x. G prime of x is inside of this radical, the radicand expression, that's the g prime. So we have to take the derivative of x cubed plus 1, which end up being 3x squared. Very good. And plus 1 is constant, derivative of 1 is 0. That's not going to affect anything, so we don't have to add 0 to this. All right, so last step, we can simplify this, and because it's a multiplication, we have 3x squared on top all over 2 times, and I'm going to change the exponential, the -1/2. I'm going to drop it down to the denominator, make it a positive half, and that becomes a square root, and that becomes x cubed plus 1 is square root of that. So this is the final answer to example number 1. Very good. This is the derivative of f of x. Let's look at the second question. So the first thing we got to do, we got to change that to the exponential form from radical form. So that comes up and that becomes x squared plus x plus 1, all of that to power of -1/3. Okay, so that's what this 1 over cube root of x squared plus x plus 1 will be. When you bring that to the top, that becomes negative exponent. I have changed the radical form to the exponential form because remember, this has the exponent of 1, and that's where 1/3 comes from. Okay, when you change the exponential form to the radical form and vice versa. Now that we have this, we have to go ahead and use the chain rule. First, we're going to use the chain rule to the entire function. So that would be -1/3 comes to the front, x squared plus x plus 1, close the bracket, and -1/3 minus 1, because you're subtracting, and that becomes -4/3. Okay, times. Now we have to look at the inside here, and we have to deal with the inside. So let's deal with the inside. I'm going to use the blue color ink to take the derivative of inside. That would be 2x. Now I'm going to open up a bracket because it's a multiplication through. 2x plus 1. Close the bracket because 1, there's a constant that would be plus 0. I don't need to write it down here anymore, and that's what you will have. Okay, so now let's put them all together and you will get this expression right here. Is a rational. So I change the negative exponent to the positive exponent and then change it back to the radical form, but you can also leave it the way it is and totally is fine, no problem. All right, so those are the two examples that we went through. Apply the chain rule. Make sure you go through them again. Pause the video, go through a step at a time. Make sure you understand the concepts and you always follow the rule. Okay, the chain rule has to be followed, and take your time when you do this. If you found this useful, subscribe, like the video, make a comment in the description below. Specifically, make a comment about any future lessons or topic that you want me to go over, and I will be happy to do that. All right, until next time, be well.